6 times 4 is 24. If I said 24 has a factor of 6, you'd know the other factor is 4. Well, similarly, they've told us that x equals 1 is an x-intercept. That allows us to say x minus 1 is a factor. We're looking for 0, so it would be really nice to know the other factor. These two factors multiplied would give us the original equation. So just like we divided 24 by 6 and got 4, we're going to divide this by the factor we know. But before we do, we're going to always look to see if there are any common factors. And sure enough, I can see 3, 6, 15, and 18. Also, x squared shows up in every term. So I'm going to start with factoring out a 3x squared. When I do, I have x cubed minus 2x squared minus 5x plus 6. I could look to group this, but I don't think it will group. Yep, I just tried it. It doesn't group. But I know that this is a 0, and therefore this is a factor. So I'm going to divide by x minus 1. X cubed divides in x squared times negative x squared. I'm trying to get to a negative 2x squared, so this is another negative x squared. Negative x, positive x. I'm trying to get to negative 5x, so this has got to be negative 6x. Negative 6, positive 6. My remainder is 0. So that means the other factor, that one I was searching for, besides the 3x squared I factored out, is right there. X squared minus x minus 6. Now I can factor that to get to any remaining zeros. X minus 3, x plus 2, the original x minus 1 that I had, and 3x squared. That gives me zeros of 0, 3, negative 2, and 1. Those are all of the zeros for this fifth degree polynomial. Why are there only 1, 2, 3, 4? Because we bounce at x squared, so that means this is really 0 2 times. Now we've got all of our 5 real zeros.